Class?
Yes.
Thank you. Thank you. I like that excitement. All right, so we're going to go through, we're going to start with the chain rule. It is one of those fun ones in which it's just weird. So, yeah. We're going to differentiate some logarithmic, exponential, for a couple other things. So, now, chain rule. Function of g is differentiable at x of naught, which is the initial, and the function f is differentiable at g of x of naught. Then the composite function f of g is differentiable at x of naught, the initial. And for differentiable functions, y equals f of u, and u is equal to g of x. The chain rule in Leibniz notation takes a look like this. So the derivative of the whole thing is the derivative of y in terms of u times the derivative of u in terms of x. Here's another way of saying this. Derivative of the inside times the derivative of the outside. Does that make sense or no? Maybe? Possibly. No? Hopefully people were paying attention there. Alrighty. Okay. You ready? This is what it means. We have all of this right here raised to the 100th power. Do I want to expand that? Hell no. I do not want to do that. So what am I going to do instead? U substitution. So I'm going to say that u is going to be x3 minus 4x plus 1, right? U prime is going to be 3x squared minus 4. All right, so let's rewrite this over here. So if I rewrite this, I'm going to say that u to the 100 power. Because we already said all that's u, right? So by doing my substitution, I said all this is u. I'm going to take the derivative of that, which is going to be 100 u to the 99th power times u prime, which is going to be right here. My board's kind of messing up here, so let me see if I can get this. There we go. Almost done. Why is it almost done? I got to put the u back, right? I substitute a u to be able to do my problem because I'm asking for it in x's, not u's, right? So by doing the u substitution, that's what it gives me here. So this, all this right here is the outside. So we're saying this here is my outside, and this here is my inside. So derivative of the outside times the derivative of the inside. Now, put it back. So I'm going to put that u back. 100 parentheses x cubed minus 4x plus 1 to the 99th times 3x squared minus 4. Does that make sense or is that nonsense? Juju? Okay. Now, Christian, what was key to doing this problem? Okay. So, if I'm looking at this, identifying my u, identifying what the u is going to be important, because when we start doing other types of weird u substitution, that's what we're going to have to use. Okay? So now, in this next one here, identify, what do I want my u to be? Huh? What's the insight on this? Very good. 3x minus pi over 4. So I'm going to say that u very good. U prime is going to be 3. So rewrite it now with my u. So that's going to be cosine of what? I can almost hear you. I think it's a fan. It's like this whole white noise thing that I can't hear anything. I'm pretty sure this room actually has the most noise ever. Because I have that thing too, and then there's like this over here. Anyway, alright. Of what? Cosine of? 3. Ooh, close. Okay, what's the outside? Very good, so it is. So the outside is cosine, right? And the inside was? 3x of pi. Okay, so what am I going to replace 3x minus pi over 4 with? U. Yeah, cosine of u. There we go. Okay, so identifying that is actually super important. So we're going to say that it's cosine of u. That should be an easy one. Cosine of u is? Think of the circle. Where's cosine on the circle? On the right, isn't it? So on top, it is, what's on top? No. Of the derivative circle. Remember the derivative circle, we start here with sine. Okay, so cosine, negative sine, and this is going this way. This is the circle for derivatives of these. Okay? So derivative cosine is negative sine. Thank you. So we get negative sine of u, right? Times three. And now what do I do? Vincent, what do you think I should do? Put the u back, right? Okay. So that's going to be, and I'm going to rearrange it a little bit. So I want that 3 up front because that's a constant. So it's going to be a negative 3 sine of 3x minus pi over 4. I don't know if you guys realize this, I make some mistakes every once in a while. What helps me to keep everything in order is identifying and listing everything, especially when I'm doing substitutions. When we get into the upper level stuff and you have a crazy substitution, some of these you're going to have two chains. So you're going to have a substitution for each. And so as you go back, show your work right this. Because I would like you guys, when you take the AP exam, show your work so you can actually show what things are. And it keeps me in order because I have to keep myself in order because it is one of those things. All right, let's keep going then. All right, differentiate a composite function. Ooh, this is crazy now, isn't it? What is my u? What is it? X squared minus 4. So we're saying u is x squared minus 4. U prime is, so as I rewrite it with u, I have e to the u. And what's the derivative of e to the u? E to the u, right? So it's going to be, the derivative is e to the u times u prime, which is, and then let's substitute it back. And I'm going to put that 2x in front too. So it's going to be 2x e to the x squared minus 4. Hopefully this is starting to make a little bit more sense. Just a little bit. Doesn't have to make a lot of sense. Just a little bit of sense at this moment in time. It will make more sense later. All right, Juju, you ready?
Yeah.
What is the u on the next one?
4 e to the x.
4 e to the x. U prime?
4 e to the x.
Yeah. Because e to the x derivative is e to the x. Alright, so if I rewrite this, I'm going to get sine of u. You ready? Juju, you ready? Alright, derivative of sine.
Sine
So I get cosine of,
4 e to the x. U.
okay, yeah, go with u, and then we'll sub it back. Times
4 e to the x.
4 e to the x. Okay, and then sub it back. So I'm going to bring it out front. So 4 e to the x times cosine of 4 e to the x. And if it was going to turn into a second derivative on this problem, this right here now is what type of problem? That's a product. Because you're going to get a lot of these that come up more complicated. So we started here with the chain rule, and if I were to try and take the next one, it would be a product rule with a chain rule. So we're going to start combining rules together. So this would be a product, so this would be my F, this would be my G. Okay, all this is G, and if I were to have to take the derivative of this, I would do the chain rule to get that derivative. I think we actually do have one of those coming up here. All right, trig rules for composite functions. So, basically the same thing that we just did. Find the equation of a tangent line to the graph of 5e to the 4x at the point 0, 5. Okay, equation of a tangent line. So, if we want the equation of the tangent line, whenever I hear the tangent line, I know I need to have what? I need to have the slope, right? And to get the slope, I have to get the derivative, right? The derivative, that's gonna help me out there. All right, so let's state my problem. Okay, and then I'm gonna U this because I have that. So my U in this case is gonna be what? 4x. U prime is 4. So I'm going to have 5 e to the u. My derivative is going to give me 5 e to the u times 4. So together I get 20 e to the 4x. And this is my y prime. So there's my derivative. And now to find the slope, what do I do to find the slope? Plug in 0 for my x. So plug in 0 for my x. So that's going to be y prime equals 20 e 4 times 0. So anything to the 0 power is 1. So my slope, because 4 times 0 is 0, e to the 0 is 1, times 20 is 20. So we're going to say that y prime, so that my slope is 20. Or I prefer writing it in function notation, which would mean that f prime of 0 is 20. So what that means is when my x value was 0, in the derivative, my slope is 20. Now, I have the slope, and I also have a, what's that thing? It's a point, right? So I'm going to use point slope. Yes? Okay. So let's go through. Y minus 5 equals 20 quantity x minus 0. Man, my board. Come on. Keep working. Keep working. You got this. Equals 20x. And this right here is my tangent. There's my tangent line. Yes, no, maybe, possibly. On occasion, yes. Say what again?
Could you explain y prime again? How it became 4 times 0?
4 times 0. Oh, okay. So, right here, we're trying to find the equation of the tangent line this point.
Oh, at X equal that.
Yeah, okay. So yeah, I put x equal to 0. That's the reason why I rewrote it over here, because I don't like it in this notation. This is saying that I'm plugging in 0 here. But in function notation, it says my function f, the derivative, I plug in 0 and I get 20. This doesn't have the same notation. So it just shows you what we get there. Alright, you guys feel pretty good about that now? Alright, before I get too crazy with this, I will pick this one right here up tomorrow. I want you guys working on the assignments, some of the problems, not sitting there scrolling through your phone. You had all weekend for that. Make sure you all like, share, and subscribe. Hit that notification button.